Hey guys, welcome back to my channel. My name is Jay, and in this video, I'll be showing you guys how to implement the infinite scroll web design. Infinite scrolling is a web design technique that loads the content continuously as the user scrolls through the web page. This web design technique has inspired social media giants like Twitter, Facebook, and many others. Besides providing a seamless user experience, this technique enables you to lazy load content on the web page. Let's try and understand what lazy loading is. A browser, when it tries to load or render a web page, the first thing that it does is it makes web requests to the web server to fetch the necessary resources that are required to render a web page. Now imagine if the content of that web page is large, then the browser will automatically create a scroll bar so that we can scroll through the entire content on the web page. In this case, we are technically loading all the information or prefetching all the information that is needed for that complete web page load. But if you think about it, if the user is not going to scroll through the web page, the information that we have loaded, which is not part of the viewport, initial viewport, is pretty useless. So instead of preloading everything at once, which is also a performance bottleneck, if you think about it, it adds a lot of load time on the browser, at least on the initial render. So instead of loading everything at once, we could load only part of the content that is required and that is visible on the viewport. And only as and when the user scrolls through that web page, we are going to request for new information from the server. This part is called as lazy loading. So we are lazily loading the content on demand instead of loading everything at once. Now let's talk about how we can implement the infinite scroll effect. The first and foremost thing that we will do is instead of loading all the content upfront, we are going to load only some part of the content and control it using JavaScript. The second thing is the part where we try to load new content based on a certain criteria. So this criteria can be based on the scroll position or based on if a particular element is within the viewport or not. So let's talk about the first one. In this mechanism, we are going to rely on a scroll bar's y-axis position, which is the scroll y position, which is a window property. If the scroll y position is, let's say, 100 pixels from the bottom of the from the end of the viewport, then we can try and fetch new content by making an API call and adding that content to the existing content that is already there within the viewport. The problem with this approach is calculating the window.scrollby position and based on that making an API call. All of this happens within the main thread. That is, JavaScript is a single threaded language, which means there is only one process that is actually running continuously. And if we try to make calculations or always try to monitor the scroll position, then it's going to impact the performance of the web page as the calculations that we make to get the current scroll position, and this has to be done continuously, right? To do that, it's going to take up some memory on the single thread that we have, and it's going to impact our overall performance. That's why a better approach is to use the intersection observer API, where we monitor one element. We take the last visible element, and then once it's loaded or once it is intersecting within the viewport, then we try to make an API call to fetch new information, and that will create the infinite scroll effect, because when you append new information to the existing content, it's going to add more content below the existing one, and the user can keep on scrolling, and out of the new content we are going to look at the last element of the newly created content. And this is like a continuous effect where as the user keeps on scrolling, whenever they bring in the last observed element, currently last observed element, it's going to fetch new content, and the last observed element will be the last element of the newly fetched content. Maybe this is a lot of information that I'm throwing at you theoretically. So let's take a look at it using an example. But before that, we are going to rely on Intersection Observer API in this tutorial. So if you haven't watched my previous tutorial on Intersection Observer API, I would highly recommend you to watch that video completely to understand everything about Intersection Observer API, because I'm not going to be diving deep into the Intersection Observer API in this tutorial, as this is only focused on the infinite scroll. So first of all, let's try to look at what would the end result of the project that we are going to build would look like, and then jump into the code. We have a web page with a bunch of codes loaded into it. And when I look at the elements, right, let's try to inspect what we have so far. I can see that there are one, two, three, four, there are five codes that we have so far. And I think there are more than five. Let's try to count this: one, two, three, four, five, six. Yeah, I think there are around six codes. And when I try to scroll through this currently, so let's go back to our elements view. When I scroll through this, if you observe, it's continuously adding newer codes to this page. So if I keep on scrolling, it has added new elements to this. So we start off with an initial list, and then as and when we keep on scrolling the web page, we continuously add new codes to the existing container. So this is the technique that we use to create new or the infinite scroll effect. And the technique that we are using here currently is whenever we add a new list of codes to the container, we try to observe the last element within the container and try to do an is intersecting on that particular entry using the intersection observer API. If this element is intersecting with the overall viewport, then as soon as it's intersecting completely, we try to make a new API call and get a newer codes and load them into the container. And as soon as we load them into the container, we are no longer going to observe this last code, and instead we are going to start observing the last code that has been added in the previous append. So this is the overall process that we are going to use using the intersection observer API. So now let's jump into the code, and I'm going to clean up the entire project, and we are going to start with a blank slate. I have created a project called as Infinite Scroll, and within this project, I have index.html file, script.js file, and the styles.css file. Let's start with our HTML file. So I'm going to create an HTML file with my title as Infinite Scroll. All right. So within this, I'm going to create my container. So this will have an ID called container. The next thing that I would like to do is to link my CSS file, and the href will be pointing to the styles.css file, which is in the same folder. Likewise, I'm also going to link my JavaScript file with the source pointing to script.js. All right, I have a JavaScript file and a CSS file and an HTML file, and everything is linked. So let me go back to my CSS file and then add some body color to it. So the background color will be, I have a color saved here. So let me copy this. Just making sure that this is actually working. I'm going to open this using live server. When I do that, I can see that it has already changed the title to Infinite Scroll, and the background color seems to be working. So that means the CSS file is successfully linked. The next thing that I want to do is I want to go to my JavaScript file. The first and foremost thing that I would do there is to have a reference to the container. In the container, I'm going to call document.querySelector with the ID as container. Let's console log this and see if we can find it. So it has returned the div that has the ID container. So the JavaScript file is also successfully linked. Now let's talk about what needs to happen when the page initially loads. So we know that we now have a reference to our container, and within this container, we want to load a bunch of codes. To get the codes, I have already an existing API endpoint that I've been using within my Postman. So this is the endpoint where I do a get call, and when I do a get call, it returns a bunch of array of objects where each object has a text and an author. So we are going to use the same URL, and it doesn't have any special authorization. So it's a simple get, and I'll be using a function where I'll call this as load all quotes. In this function, within this function, I'm going to use the fetch API. Fetch API is an inbuilt API, browser API, that lets you fetch for information or resources from the web browser. It uses HTTP, and there is no need to import any library because it is part of the browser. It is part of the browser. So what fetch does is it's going to fetch the information from this URL, and this is going to return a promise. Fetch is going to return a promise. That's why I'm going to use .then, and within then, let's see what we have. So within then, we need to call this function first. So I've declared it. So let's call load all quotes. This has given a response. So let's try and get the response.json method. So res.json method. When I do response.json method, it returns another promise. So response.json is another promise. So what we are going to do is we are going to return that promise from this then block and chain it to another then because this has also returned in a promise. Now within this, I'm going to get all the codes. When I do console.log of codes, this should result in the array of objects that we have seen. So when we go back, you can see that there are 1643 objects within an array being returned. So let's go back and save this information somewhere globally within this file. So I'm going to call all quotes. I want to store this information somewhere. So I have a variable called as all quotes, which is of type array. And I'm going to store the response, which is quotes here, and save all of the quotes within the all quotes array. So I'm going to call all quotes equal to, instead of directly assigning it, I'm going to do a spread operator on all quotes and also a spread operator on quotes. What this means is all quotes will be replaced with a new array where it's going to get all the values of all quotes. Currently it's empty array, and it's going to get all the values of quotes. So that is like 1643 array of objects. So objects, it's going to put all the objects within this array, and this total new array will be assigned to all quotes. That will be my all the quotes that are coming from the API endpoint. All right. The next thing that I want to do is I want to have a mechanism to render my quotes. So I call render quotes where we don't have a definition for that yet. So let me define a function called render quotes. All right. So within render quotes, what do we want to have first? Within the render quotes, I need to be able to format or come up with. I want to read what's going to be there within the object on each array item, and I also want to do one more thing here. The thing is, I should be able to selectively pick a slice of the array. So I'm going to start from, let's say, the limit that we are going to have is we're going to load 5 quotes um, every time. It's going to load with 5 quotes for the very first time. And so I want to be able to tell the slice function on that array to only render uh, array of objects from 0 to 5. So that's the first thing that I want to do. And then after I do that, I want to be able to render those quote values like the text and the author in a div. So I want to create a div format and then give it a class and some sort of styling. So let's define that, right? So first thing is um, we should be able to define the range of quotes. So that is 0 to 5 first time, right? Second thing is after we get that information, should be able to format the info in the form of divs, right? And then finally render that info uh, as part of the container. So these are the 3 things that I want to do within this render quotes. So let's start with the first one. What I should be able to do now is all quotes is the total array, and within all quotes, when we do slice, what this is going to give us is um, 2 indexes, that is 0 and 5, the start number and the end number. So let's try to console log this first. So when we console log this, we can see that there are like 5 array of objects that we got from the total all quotes array. Now let's we need to pass this information, all quotes of slice 0 to 5, into a formatter function. So which is the second one here. So I'm going to create a function called as format quotes. The reason why we are doing format quotes is we want to be able to get that information as part of as in the form of HTML, right? Because eventually we need to convert all of this piece of information. Right now it's properties, right, in the form of an object. We want to convert this into a div and then show it on the web page. So let's try to format that. To format that, first thing I'm going to do is I'll create a quote string. Um, so this will be an empty string initially, and this is going to accept a parameter called quotes. Quotes will be our sliced array, and we will be looping through the quotes, each quotes, and each parameter will become a quote. Here we are going to call it as quote, and return quote string. So we are going to append each quote and reading the property like the text and the author, and we are going to append that to the quote string here. So quote string will be I'm going to do a plus equals to, that is an operation that we do on a string, and within this I'm going to use an append. I'm going to pass in a string. Uh, this string will be used to read. This string will have the contents uh, in the form of a div, and here I'll be reading quote dot text first, and I have a space and a hyphen, and then I'll have quote dot author. So this is going to loop through all the 5 array of objects, and for each object it's going to create a div and it'll start appending it to code string, and finally we are going to return the code string. So this will result in an HTML string. So that's the idea of adding this helper function, which is called as format codes. The last part is where we are going to append it to a container, where we already have a reference to our container. So let's start with the first job. Uh, First thing that I want to do is um, const uh, const, and then I want to say um, get codes, right? Get codes equal to format codes of, let's do this, all codes from 0 to 5, and let's do a console log on get codes. So when we go back, we are seeing that we have a div with multiple divs actually, with the quote text, and then we also have the author. Now let's use that information and append the that information in inside the container. So I'm going to use that to do get codes, or I'll just say uh, latest codes. Yeah, that's a better name. Latest codes equal to container dot inner HTML. So this will be an append operation, and that's how we are going to have our latest codes rendered. So if I go back, we can see that we have our first 5 codes where we are able to render the code text and also the code author separated by a hyphen. So this looks good. Now let's try and add some class to this so that we can use that class to style our codes. So I'm giving it a class of code. When we go back to our CSS, let's start off with the styling the code. Now let me give a background color of Alice blue, and Alice blue is the color. And if we switch back, okay, so it has added some background color to it. Now the font size of 23 pixels, okay, and let's add some padding of 40 pixels and 10 pixels, 40 pixels on the top and bottom and 10 pixels. Let's also add a margin of 20 pixels. So we have 20 pixels on the top and bottom. Now let's say what else can we do? Let's also add border radius of 10 pixels to give it a nice rounded edges. The last thing maybe that we can add is text align center to this to center the elements. So this is one thing that we can do, and let's also add something here to our container. So I'm going to target my container, give it a display flex, justify content center, align item center, and the flex direction will be column. So we have it displayed as a flex. All of these have become flex items now. The other thing that we can do here is to have a width of 70%, so that we'll have uniform size to it. As you can see, there are only 5 elements. Because we have only rendered 5 elements, we can see all the 5 elements rendered this way. Now that we have styled our code class, I mean divs with the class of codes, let's go back to our JavaScript. So we were able to achieve all of this. We got the first 5 elements, and we got our we formatted those elements in the form of divs, And lastly, we were able to append that information, all the HTML string that we got, and we have put it, we have appended it to our container. So that's how we were able to render these first 5 elements. Now the idea is to look at the or observe the last element of the current set of codes. So far, we have 5 codes. So the last code, to get the last code, we are going to do container dot last element, container dot child of last element, or we get all the codes by using the query selector all dot code, and then we get the last code of that and try to observe that element using our intersection observer API. So let's do that. So now that we have added the codes here, let's also try to fetch. So we need to fetch all the rendered codes and get a reference to the last code. So this is what we are going to do now. So we are going to create a new variable called rendered codes. In this rendered codes, we are going to have document dot query selector all. The query selector all will um, look for the class called code. In this, let's console log the rendered codes. If I go back and right click and do inspect, uh, let's see, be able to define. I think there is some sort of typo in the function. So let's see what's wrong here. Rendered codes, container.html, document.query selector all, and the value of it is code. Okay, it should render it correctly. Let me try to refresh. 23, line number 23. 23. Query selector all. Let's see what's going on here. Constant rendered, oh, rendered codes, and I haven't given the right name within the console log. That was the issue. So when I saved it, we are getting a node list of 5 elements that is expected, that is 0 to 4. And we want to access rendered codes and rendered codes dot length, rendered codes of rendered codes length minus 1. So that's going to give us the last element, last rendered element. Rendered codes. Yeah, I keep typing the function name here. So rendered codes dot length minus 1, which is the last code that has that is this one here. So now we want to observe this element, and as and when we have this element intersecting with our viewport, we want to load 5 more new elements, so that we should be able to scroll, right? Uh, let's try to do that. First thing I want to do here is I want to create an intersection observer API, create an instance of intersection observer API. So this will be, I'm going to create an observer with new intersection observer. And within this, I'm going to define my callback function and call the parameter or the element as entry here. And it's actually entries. Let's call this entries and console.log of entries. So right now we won't see anything here because we haven't observed any element so far. So here I'm going to start observing the last rendered code. Let's do this actually. Instead of having rendered codes of rendered codes minus 1, I'm going to create another variable called last rendered code, which is going to be rendered codes of rendered codes dot length minus 1. So I'll be observing the last rendered code. So this I got a reference and I'm observing now. So observe the last rendered code. This way, now we should see a console log for the last rendered code, because last rendered code is already part of our root elements intersection. We should see an entry for that on the browser. Let's double check. So as you can see that we have an intersection observer entry, and it should have is intersecting to true. So that is expected because we have the last element intersecting with the root element. Now, what do we want to do here? If it is intersecting, then we want to um, load load new content, right? We want to render new codes. So let's do that. So first thing I want to do here is I want to go through entries.forEach because it's an array-like structure, and this will become an entry. Each of this will be an entry. If entry dot first thing I want to do is if it is not intersecting, I'll just want to return. I don't want to execute any logic. If entry dot is if not, right, if entry dot is intersecting, if it is not intersecting with the exclamation, then I just want to return from this loop and the function. I don't want to execute anything further. But if entry dot is intersecting, then in this case what I want to do is I want to render new codes. I want to stop observing the existing element or code in this case. So I want to stop observing this code. Yeah, that's the first step that we want to do. And then we want to render new codes, right? We want to render new codes. These are the two things that we want to do. So to stop the current one, what we need to do is we should use observer dot unobserve, and this takes in an element. So entry dot target is the actual element. So we are going to stop observing that. So when I go back to my browser, we will see a log, right? We already see a log here. But when I move it out of the viewport, actually, there's no way we can move it out of the viewport. Let's come back to that. Let's come back to what unobserved does. But now I want to create render codes. So render codes in this case is going to call this function again. So let's look at that. So it has called that function again, but the only problem is it has repeated codes. So it rendered 0 to 5 again because we are slicing 0 to 5, right? That's why we need to create some dynamic values. We need to make sure we have some sort of dynamic values here. So first thing is I want to come up with a render limit. Render limit or let's say quota limit. So each render, for each render we want to render 5 new codes, right? So that's why I'm going to replace this with quota limit. But this value, instead of starting from 0 all the time, let's give it a variable name called starting index. So it starts with 0, starting index starts with 0. And what will happen now is what we need to do here is starting index it needs to be updated, right? Because whenever you add or append the container.inner.html with the latest codes, then the rendered codes value gets increased. So that's why what we need to do is starting index needs to be changed. So for that, I'm going to make the starting index to point to rendered codes.length. So that will that way we know that, let's say if it is let's actually stop this first. Um, what should happen here is whenever we add a quote here, let's say whenever we add a bunch of quotes to the container, it will increase the length of the overall quotes, right? Query selector all of quotes. At that time, we want to change the starting index to uh, the last one. So the last one plus one, right? Because the indexes start from zero. When the first set of quotes are loaded, um, it's going to render from 0 to 4, and my starting index should be 5, so that in the next iteration I'll be able to start from 5, fifth index, and the quota limit should be starting index plus uh, quota limit, which is 5, so that will be 10. And once we get the next set of quotes, the overall container length will become 10. So from there, I'll be loading from 11 to 15 and so on. So that's the idea of making these values dynamic. Now let me go back and add render quotes here. So when I do that, you can see that so there are two intersection observers, because the first one we are already observing it, and is intersecting is true for that. Because it is true, it has loaded another set of 5 codes. So in total there are 10 codes now. But the last one, when we add the last, when we update the container.inner.html, then we are observing a new code now. So after the intersection is complete, here we are unobserving the fifth code, which was the previous last code, and we have triggered render codes. Within the render codes, we appended a bunch of newly created 5 codes, and now we are starting to observe the last rendered code, which is the 10th code in our case. So whenever we do the observe, it immediately logs an intersection observer entry, but this time is intersecting will be false. As expected, is intersecting is false because that code is not yet within the viewport. So I'm going to scroll through all of these values now. So when I do that, I have hit the 10th quote, and 10th quote, so the is intersecting value of the 10th quote will be set to false. But now the is intersecting value of 10th, sorry, is intersecting value of 10th quote is true, and is intersecting value of the 15th quote is false. So this way, we are going to achieve the infinite scrolling effect, because whenever we load the newly created elements, we always change the last rendered code to the last element of the container child, and then we are going to start observing that. So this way, we are now able to achieve the infinite scrolling effect. Hey guys, if you've learned something from this video, please like and share this video with your friends. Also, consider subscribing to my channel, as I'll be posting more videos on web development related content on a weekly basis. That's it for now. I'll see you in the next one.